Hello and welcome to session 3BI at GSE UK 2021. This next session will be provided by Kelly Voigt from BMC Software, and this is on the many benefits of proper batch initiation. Oh my goodness. Please, if you have any questions, put them in the chat, and Kelly will get round to them at the end of the session. If you want to talk, I will allow you to unmute yourselves at the end of the session as well. Okay. This year's charities are the Guide Dogs for the Blind and the RNLI, the Royal National Lifeboat Institution, both of which are extremely good causes. And if you dig deep in your pockets and give generously, for every £1 you give, you will have entry into the GSE raffle. So good luck with that. Your generosity may well be rewarded. With that, I will hand over to Kelly.
Hello, good afternoon. My name's Kelly Voigt with BMC Software. I've been in the business a little over 40 years. This is interesting, the RNLI Lifeboats charity. I had the pleasure of enjoying Sennin Cove in Cornwall in the UK, right out there near Land's End, and stayed across the street from the light pole station, and they had a big event while we were there. So great place to visit. I highly recommend it. So on to our agenda. First, I'd like to talk a bit about what an initiator is and how it selects work. But the one thing I really want to ring through is a new way to think of an initiator. And you'll see what I mean. Then I'd like to talk about what job initiation is. I'd like to cover the subjects of over-initiation and under-initiation, and talk about what I call proper initiation and the reasons why improper initiation occurs. And then finally, I'd like to talk about the impacts of over-initiation, because it's a really bad thing. And it's highly related to batch, almost entirely related to batch, and people need to be aware of it. So I'd like to talk about how it will increase job elapsed time and increase job CPU time. Okay, so for the uninitiated, if you'll pardon the pun, let's talk about what an initiator is. On the screen here should be very familiar to most people. There's a whole load of initiators there, but it is a batch processing environment. I would regard it as almost akin to the first virtualization that was done, the first virtual machine really in the world of batch, and that's all it was back then, was the ability to run multiple batch jobs concurrently on the same machine. You think of it as a reusable, it's a job type address space that's reusable and gets reused because the initiator code resides in there and repeatedly requests work from JES2. We'll talk about how it requests that work. Okay, but the thing about initiators is it's really, really hard to capacity plan for batch. It matters, a lot of things matter, particularly the available capacity for batch at any given point in time, because in a batch, in a machine with batch and perhaps other workloads may expand and contract and therefore reduce or increase the size of the capacity available to run your batch, for instance. The number of physical and logical CPUs in the environment matter and impact the batch as well. CPU speed is also a concern, and keeping your CPU speed up, keeping your MIPS up and not degrading your environment is important. Then real memory everybody thinks, oh, we got loads of memory. And yes, we do, but more and more we have applications that use lots of real memory with data in virtual technique. I mean, just look at sort, for instance. Sort might get gobs and gobs of memory and put the whole file in there and sort it in memory and not do an IO for a long period of time, for instance. And then, of course, the volume of batch jobs, it's pretty much growing everywhere. I visit every customer I talk to, it's growing and growing. And then the dreaded SLAs, the requirements, those are, you know, batch windows are seemingly shrinking all the time. We want, especially in shops with applications that can't run alongside their onlines, which takes a lot of investment to overcome usually. And there's other reasons. So it's very difficult to plan and properly have the right number of initiators at all times. And there's consequences to that. So what are the types of initiators? There's two types primarily. There's JES2 initiators, which are, you know, under direct control of the operator. The operator has complete control over them. And he can manipulate them in mass, or he can manipulate them singularly, starting, stopping, and modifying job class assignments and such. The other type are WLM initiators that IBM brought out many years ago and really haven't done much with. They're not managed by the operator, although the operator will manage the work going to them somewhat. But they're under the control of the master subsystem, and WLM decides the number to start and run in environments where the work is allowed to run. A lot of shops use them sparingly. I haven't really seen a shop that just went wholesale use of them. That doesn't happen. People have opinions about their usefulness or lack thereof. So operators can control the number of jobs in execution in the JESPLEX and upon any member with a variety of commands like, you know, the $T job class commands, where you can control the queue affinity, where a job class can run on which member or members. You can also control, you know, how many initiators actually get used for a given job class with XEQ count and XEQ member parameters on the $T job class command. You can control the flow of jobs into execution, which is another way of looking at it. For JES2 initiators, you would use the queue held command. You can hold the queue on a given member or entirely in the Plex, for instance. And for WLM, you're going to be using the $T service class, which is just kind of an on and off valve. So, so how does an initiator end up selecting work? Well, let's talk about them a little bit first. They all have a number, or you can give them a name, as you can see here. You can have up to 8 classes associated with each initiator, and there's all kinds of schemes on how classes are laid out. You may have 1 class, you may have 2, you may have up to 8. For a long time, we only had a single character job class. We had 36 of them, the alphabet and the digits, and customers wanted more. It wasn't enough, so IBM came up with the 8 character job class, which led to a rash of frivolity, people picking clever names for their job classes, etc. I guess even people running batch want to have a little fun every now and then. So, you know, initiators can be started, stopped, halted, drained, and so on and so forth. But initiators will select work. They pull work from JES, the JES subsystem, by making requests by their job class string. So they say, give me a job, and job selection looks for a class A job, a class B job, then a class C, goes down the list until it finds one. And then it can only actually select what are referred to as as eligible jobs are selected. So what are eligible jobs? Well, let's talk about what are ineligible jobs. So ineligible jobs are like jobs that are, say, submitted on hold or held by the operator, or jobs in a class that's been held. Like I mentioned before, the $T job class, you can hold the whole class of work from being selected. Or the whole execution environment might be stopped with the $P execute command, which essentially says cease processing batch. Another ineligible job could be a job with a duplicate job name. For in MVS and MVSXA and ESA and ZOS, for a long time, you could only run a job with a single instance of a job name, could be an execution at a time. That was finally changed, and there's control over that with JES parameters called duplicate job equal delay or no delay. So if you've got no delay coded for all jobs or for the job class being requested, then you won't be able to select that job. The initiator will not be able to select it. Jobs with member affinity, a job running initiator on SysA cannot select a job that has a member affinity of, say, SysB, for instance. So he'll pass that job up when he's running down the queue trying to find one. And then finally, scheduling environment affinity, same thing. A scheduling environment might be active over on SysC and you're on SysB trying to pick a job, and it just doesn't match. So let's move on and talk about a new way to think of as an initiator. I look at every initiator start and the subsequent torrent of jobs that will run through it like it's like writing a blank check. Okay, why is it like writing a blank check? Well, the reason is that initiators are just blind to what's going on. They blindly select jobs until there are no more eligible jobs, and they run them. They run them, and the jobs do what they do to the system. Let's put it that way. Job selections absolutely unaware of any impact the job might have on CPU, memory, IO, or any consumption rate thereof. Okay, so it's just kind of a dumb thing that grabs jobs and runs it no matter what. And essentially, if you're not managing job selection, nobody is. If you're not managing job selection is managing you, because if you're the operator, it's determining just how good a day you're having or not. So I like to look at it this way. Job selection, it has consequences. So job selection methods should be thoughtful and goal oriented. And in most shops, there's nothing. They're not a job selection exit or anything, or a product to do it for them. It's all left to the operator's wits. So let's move on to initiation and what that is. Okay, so initiation is when a job gets selected and gets going into execution. So what happens is the initiator loads the JCL, the converted JCL, interpreted JCL more correctly. It's a bunch of control blocks, and those get loaded into the initiator, and those control blocks are used to prepare the job for execution. Things I like to point out are like allocation. Device allocation occurs. You might need tape drives, virtual, they're still devices. Disk drives are actually devices, kind of forget about that. And data sets are allocated. Data set allocations take place with the required NQ strength as the JCL specifies. So what does NQ strength mean? So NQ can be either a share, which means I want a data set and I want it shared, and I'm able to use that data set with anyone else who wants it shared at the same time. We can all read into that data set, generally no writing. And so it makes it available to anybody. And then there's exclusive. Okay, so Dispo, Dismod, whatever, that's going to get an exclusive NQ. So the job attempts to, allocation attempts to get all those data sets. And when it can't get all those data sets, you kind of have a allocation failure that ends up resulting in an operator dialogue to determine what they should do with that situation, which usually means, you know, getting rid of, maybe canceling a job or something like that. Okay. So let's say you get through allocation, and in simple terms, the job step setup begins. And so what is setup? Setup is making sure that those data sets that you want are actually available for processing. So archive data, there's a lot of archive data that in the system, if you have a hierarchical storage manager, and everyone does, because nobody has all the disks they want for every data set in the shop all the time, then you're going to have archive data sets that have to be recalled either from HSM ML1, which is the, you know, condensed data sets on disk, or ML2, which is a tape data set. So that recall has to be done. Tape volume mounts have to be done also, unless the user is coded to defer on the DD statement. And those can require a recall of a archived virtual tape on the back of a virtual tape system, because not many shops have all the virtual tape front end cache to hold every volume they have. So there's going to be some activity there, and those take time, and those are done serially, one at a time. Okay. So you get through all that, you get that first tape mounted for each data set, you got access to everything, then the job starts, you get that HAS 373 message, and the initiator job step TCB will essentially attach the job step program, which is the program equal on the execute card. And that gets loaded out of the step lab or job lab or wherever it's coming from. And execution begins. Following program execution, the initiator gets control again and does sort of they call it allocation again, but it's a deallocation of devices or data sets no longer needed by the job from that point. If data sets in step 1 are still needed in step 47, then they're going to stay allocated. The job doesn't give up anything. And then it's a rinse repeat from here, everything except the job started message, of course. And at the end, you get this job ended message. The job moves on to the glorious world of JS2 output. And away we go. So how do some of these things we just talked about affect batch throughput, which is what you want? You want all the work done as fast as you can get it done. Well, first of all, the job allocation delays, they're bad because they leave a job sitting in the initiator doing nothing, waiting for the operator to decide what to do. Hopefully the operator's not gone to lunch. You could have multiple jobs waiting for a single data set quite easily. And when these waits occur in allocation, like you're not using the initiator, you're not working on the CPU, something else is, and then the allocation delay is resolved and boom, everything starts up. So, you know, there's a little bit of a liability that can build up there with data set weights and such. The archive data retrieval, it occurs on the step boundary. So every step can be a stall, particularly at busy times. You may have 10 job steps and 10 times wait for some sort of recall or tape mount activity or what have you. Why this is left to job step execution time by design is beyond me. It seems an easy thing to win, an easy win to be made. And then, like I said, every virtual tape volume mount will cause a delay staging operation. So, you know, in shops, you try to plan for stuff in your batch, but storage management might decide your data set's just too big for disk now. It's a sequential data set. We're going to move it to tape. And suddenly the way your job behaves the next time you run it at month end is different. So now I'd like to talk about this thing over initiation. Let's describe what it is. I look at it as it's like an overcommitment and a prolonged overcommitment of the available CPU capacity to execute all the work in the system and process. It's an overloading of the system, okay? And I think everyone that's been involved with batch is familiar with it. Another way to look at it, more technically, it's an excess number of work units presented concurrently to the processor for CPU dispatch. So there's a big, long queue of work units waiting to get on the processor, okay? It comes down to this. So you can start all the batch you want, you can start all the jobs you want, but in the end, you're not going to get what you wanted. What you want them to do is you want them to get done. You want them to get done as quickly as possible, and you want to meet your SLAs. But in a lot of shops, for various reasons I'll talk about, jobs selected and initiated is viewed as progress when actually it may be quite the opposite. So if there's over initiation, there must be under initiation, right? So what is that? Well, under initiation is essentially wasted opportunity, okay? Like the minutes, hours, days of each of our lives, it's time that can't be saved for later. You have to use it now or it's gone forever. And wasted opportunity is wasted CPU time. The moment's gone, it's gone forever. So you hope it only occurs like at times when large dumps of batch jobs finish processing. A lot of scheduling practices might at the top of the hour just drop a ton of work into the queue. And so, you know, you'll see a period of over initiation and then toward the end, a period of under initiation where the work is processing off and you get into a good place for a while. And then there's no more work. And then there's like a famine of work. And then boom, it happens again at some other hour. You know, when you're stuffed full for endless hours at a month end or something like that, it's very bad when there's batch available to run and it's not being run due to some neglect or mishap or misunderstanding. So this situation kind of reminds me of this little plaque we had on the wall in the house where I grew up. We have some German heritage, and it's the hurrier I go, the behinder I get. And I think that happens a lot in the operation of batch. It does in my experience. So we talked about over and under initiation. I'd like to talk now about what I call proper initiation, okay? And what is proper initiation? Well, that's where batch is running at what I call machine speed. It's running, the machine is running the work as fast as it can, relatively. And when you're running at machine speed, there are delays are minimized in a properly initiated system. And there's very little opportunity waste occurring. So you're getting a lot of throughput. It's just humming along great. It's in the sweet spot, as we say. And being there between over and under initiation is like walking a tightrope. But if a tightrope walker stays in the middle of it, you can see them run across a tightrope. Okay, it's when they go one way or the other when they slow down. So speaking of the sweet spot, I like gold sugar bowls. In any system, okay, mechanical or electronic, even computers particularly, there is a sweet spot where just the right amount of work is executing in the machine, and at the same time the machine is running as swiftly as possible, as quickly as possible. There's very little waste. waste of that time to get machine instructions done. So, there's a lot of causes of improper initiation. Let's talk about those. The first one, foremost one, by and large, JES 2 is a manually operated environment. It's manually operated. There's little things that kind of work automatically, but that's not automated. Okay. And the controls are, they're not the best. I mean, JES 2, don't get me wrong, it scales extremely well for what it does. Particularly on the output side, the input side, collecting output lines from jobs as they run as fast as they can run, as many as can run as fast as they can run. It can haul all that freight. It does a great job, but it's not automated, and the controls are just a collection of switches and valves. That's simple. They don't have intelligence, and it's very command intensive. So I've talked to shops that issue tens of thousands, almost 50,000 job and initiator related commands a month. That's an awful lot of commands. Somebody put a lot of time. I mean, if it's a minute or two per command, come on, that's a lot of time to operate. And you got to know how. So more causes, okay. The JES 2 architecture, it really has some shortcomings, particularly for throughput and over initiating. Like I said, the job setup, it impedes the job step progression, data set contention impedes the jobs getting started. Those are causes of over initiation and certainly impact throughput. The job class queues and initiators, they're all independent of each other. To JES 2, any job is as important as any other job. It doesn't know any different. It doesn't care. Jobs tend to execute on the system where they are submitted. So, you got a job scheduler, it's dumping jobs usually on one LPAR, and that LPAR tends to get overloaded. Okay. Which leads to out of balance situations. You have multiple LPARs and you have one in feast and one in famine. So you're not getting a balancing, and you're wasting opportunity. You're overloading a system often, and the other one's underloaded. And it just lacks any self-awareness whatsoever. That's a big problem, and it's been that way for decades, and it needs to be improved. If you agree, you might want to look around for a product to do something with it. Another big reason, too many job classes. So, 36 job classes, 36 workloads categorized in your system. Like I said, IBM gave us 8 character and gave us 512 total capable job classes. Good night. You think that might just make things worse? I mean, the job class is the only way to categorize the work. And in my experience, they never seem to retire. Once a job class is built and people start using it, it never goes away. Okay, so you get this sort of job class sprawl in shops, and we've seen them with 50, 60, 70 job classes. I mean, come on, how can you possibly manage that gracefully? And all job classes, again, are all the same to JES 2. It doesn't matter. The other thing is that for every job class, there's going to be at least one initiator on the end of that, sometimes more or a lot more. So, it's all these job classes lead to opportunities to start more work that shouldn't be started. And stopped advancing, hold on. Job classes don't care, that's the thing. So another reason for improper initiation is shop practices, okay? Some shops have this static initiator structure. Well, we did a study way back in '78, and we decided we needed this many initiators, and this number of job classes. And that's what we run, and we don't change anything. We don't do anything. We just, quote, let it run. And of course, one size fits all rather poorly, doesn't it? Nothing like something tailored if you want it to fit well. Shops don't plan generally for peaks. You know, are they looking at what's coming? Are they getting information? Well, they might not be able to get information. And besides, no plan survives contact with reality. And then what usually happens is shops constantly manipulate the environment. Sorry, my throat. It's the most flexible way to run the shop, but it's an endless task, and it takes people that know what they're doing. One second. Beg your pardon. Which leads to my last cause of improper initiation, and we're all guilty of this. There's a constant pressure to start jobs. Operators are pressured. The phone rings, bosses get that into execution, they're complaining, you know, all kinds of reasons like that. And there's too many jobs to discern priorities. The operators can't do it. I mean, they're human beings. They don't have the info, they don't have the time, you know, the brain power. Only automation would be able to do it properly. Job schedulers dumping work, like I mentioned before, all these things cause problems. So they cause impacts. So what are the impacts of over initiation? Well, just ask an operator. You'll get things like, you know, it's dragging, man. Nothing's moving, nothing's finishing. I don't know if we're going to get done, you know. But what else is happening? Well, what's happening is you're having a general performance degradation in your service classes across all your WLM importances. And I'll talk about why coming up. And the other thing is, it takes more CPU time to do the same work. When you're over initiating, it takes more CPU time to do the same work than if you're running in a properly initiated system. Gee, I wonder what impact that has on your licensing models. Tailor fit pricing, reporting a peak rolling 4-hour average, software licensing, all kinds of things. So that's the impacts, and they're expensive. So why does over initiation increase your job elapsed time? Well, look at it this way: the core, the chips, and the CPU chips in a Z machine, they can do one of two things. They can either execute a machine instruction, or they can prepare to execute a machine instruction. Okay. Machine instructions are comprised of one or more processor cycles. So think of that 5.2 gigahertz chip set that's used in that Z machine, 5.2 gigahertz, 5.2 gig cycles per second, okay, on each chip. So machine instructions are made up of one or more of those. So think about how this is used. So if the instruction and the related data, if there is any for that instruction, resides in the L1 cache, then this is the most productive use of processor cycles. Okay, those cycles are being used entirely to run an instruction. And therefore, the CPU executes instructions as fast as possible. So you're getting the most out of your investment. But let's look at the other opposite of that. If the instruction and the related data do not reside in any processor cache, it's down there in memory, then this is the most unproductive use of processor cycles. And the CPU instruction speed is the most degraded because we're using these processor cycles to do a lot of work, getting the instruction, getting the data where the CPU can actually act on it. So processor cycle productivity will vary depending upon how much work is in the system and the type of system activity. But here's a tendency. As more and more programs require CPU dispatch, then the more cache thrashing is experienced, because cache isn't infinitely large. They make it as big as they can, but it's hard to make a lot of that where it's as fast as it needs to be. And so the more thrashing is experienced, the more unproductive use of the processor cycles increases. So you're getting more friction, not more forward motion, okay? And this is all reflected in your cycles per instruction. And that indicates the processor instruction and cycle efficiency. Cycles per instruction. That goes up, it's worse. It goes down, it's better. So the depth of work units that end up being queued for the processor dispatch, that increases when the MIPS degrade. So it makes sense. Machine slows down, work backs up. I mean, it works in mechanics. A wood chipper, cram too much in, it goes slow. CPU, cram too much in, it slows down. Fortunately, RMF samples the queue depth of CPUs and reports in a distribution buckets the work units awaiting CPU dispatch. So that's something you can look at. So if the CPU end up degrading, and therefore the more unproductive processor cycles are occurring, then the current running work unit is just going to take longer to complete. And the CPU dispatch queue is going to grow. So if you're in that queue, let's say you're at the bottom of the queue, you're in a queue at a store, okay, and you're at the end. So if the processing of the transactions is delayed up ahead in the store, if it's slow, if it's a slow checker, then not only are you suffering the currently checked out person, but everybody in front of you is going to be slower too. So you're going to, it's like a multiplicative impact. It's going to drag. The further down the queue you are, the more you're going to suffer. So in this way, your batch elapsed time elongates. Essentially what's happening is your CPU is degraded. You bought 1,000 MIPS and you're not getting 1,000 MIPS. You're not getting 1 million instructions per second. You're getting somewhat less. And this is normal. This happens all the time in the machine. But with over initiation, it's happening to an extreme. Okay, so various workloads run at different speeds in a Z machine. But when you're over initiated, it's an extreme situation. So I want to show you some data here, okay? So here on the left, we have an over-initiated run. Let me explain this. This is a before and after. This is a identical workload, a very large workload. This is the before measurement. This is the after measurement in a controlled experiment. So here with a JES 2 running by an operator, it's over initiated and it's showing a huge number of intervals with massive queue depths. So this color here, 150 or more work units for most of the RMF intervals across, a lot of this, or at least more than half in the whole duration of this batch run, okay? So the machine was degraded where you see all this red, the happy colors are green and purple and blue, the red, orange and red, all bad, long queues, machine running suboptimally, badly suboptimally, slower MIPS rate. Okay, with automation in our experiment with automation, much happier place, much shorter work units, machines running, very much in a sweet spot. None down here, none, no queuing at all down here for whole lots of it. So this is the value of automation and controlling how much concurrent work is in the system at the same time, if you're paying attention to that. So much improved over here. The result was a 25% improvement in elapsed time. This was like 100,000 jobs. This is 20 hours, okay? 20 hours here, 15 hours. Same workload. That's an astonishing result. And this is what automating batch execution can do for you. Operator cannot achieve this, impossible. No way. Can't do it fast enough. So let's finally talk about why does over initiation increase job CPU time? And this is probably real obvious to you, but I'll just go through it. Instruction and data fetching into cache, they both take processor cycles. So the instruction execution takes a productive processor cycles, and the fetching and loading takes unproductive processor cycles, but it takes all of those. Okay. So processor cycles take time. They take time. So if the processor cycle time is attributed to the program running it, okay, people think about, CPU time in terms of machine instructions executed. CPU time can be turned into some number of machine instructions if you do the math. Well, no, it can't. Not really. You should think of job time on the CPU. I think of CPU time as job time on the CPU. It's on the CPU doing both productive and unproductive tasks. Okay. So in that way, the job CPU time elongates. But it gets worse, particularly for workloads, not just, this might be sequential batch up here. Well, let's say you're using a DB2 system and you're using it hard, okay? DB2 time is attributed to the calling program as well, but that machine degradation that's being experienced in that over-initiated system, it's hitting everything. It's hitting DB2 too as well. Sorry, DB2 as well. It hits all WLM importances, maybe a little less at the top, but it hits them anyway. And so it increases CPU time for all workloads. So your subsystem time is elongated as well as your job step program time in and of itself without the calls. Okay. So over initiation, very bad, cost you time and it costs you money. So in summary, okay, JES 2 is a manually operated environment. It's getting too big to be manual. Every company automates when they get too big. This needs to automate too. Your batch can execute much faster. I'm sure most every installation, your batch can execute much faster than it does. Okay, you're getting a job done, but it might be costing you in the long haul. The design of JES 2 makes an awful lot of work for the operator. Gee, it must be manual. Okay. Job selection has consequences. And again, improper initiation is costing you precious time and money, period. So that's what I have to present. If there are any questions, please ask.
Okay, so I haven't seen any questions in the chat, but I'm going to allow you to unmute yourselves. Okay, so you can now unmute yourself if you have a question for Kelly.
Well, I have a question, if I may.
Of course.
Would anyone care to volunteer? How many are using WLM initiators and how extensively are you using them? I'd like to hear of your experience.
If you don't like to say out loud, you can put it in the chat.
Kelly, one thing you mentioned, you know, obviously in TFP, the more CPU it uses, the higher your tailor-fit pricing consumption MSUs are. But you also mentioned you saved a lot of time. So if the customer has a batch window problem today and you've reduced the elapsed time, then you can cap it to a much lower cap and have a lower 4-hour rolling average.
Absolutely. Good point. Okay, well, if there are no questions, feel free to contact me with an email. Would really appreciate some feedback on my presentation.
Yep, so don't forget to do your feedbacks for the session 3BI. You can use the QR code, or you can use the link, or in your bring your own agenda, you can click there to provide your feedback. So plenty of links for doing that. And please note, when you do your feedback, question number 2 is about the length of the session. The correct answer would be 5, not 9, because that would just say it was super long. And again, please show your appreciation for all the effort that goes into this conference, and to the speakers in particular for the work that they do in putting together the session. Yep, charity donation is the best way to show your appreciation. If your customer is not already, if you are not as a company already a member of GSE UK, you can become a member. You can become a member of GSE. There's the GSE in most countries, GSE Europe. But in the UK, you can become a member of GSE UK, either as a company or individually. As a company, there are a lot of benefits, free places at the conference, which we hope will be face-to-face next year. COVID situation, really. And yeah, if there's no other questions, then
yes, sorry, I did have a question. I'm sorry, I just put it in the chat. I was just wondering if the only solution to have proper initiation is to use an automation tool, or is there anything else that you would suggest?
Well, the automation tool, or you would need to extensively code just 2 exits, probably.
I see. Okay, thank you.
I mean, you want something that's tailor-made to address this, and there's product in the market for that.
Yeah, in the scheduling tool IZWS, you can set all your SLAs or your job durations. You can set the limits for the number of jobs you want to run, and you can also get it to submit the most urgent work first in order to keep within your 4-hour rolling average.
Yeah, you can. A lot of shops try. That has mixed results. Again, it's a decision at a point in time, but with automation is constantly measuring the system and taking action continuously. So, you know, decisions made at a point in time usually don't have a very long effective life.
Yeah, you probably want to use a combination, because obviously your batch scheduler knows what it's about to do as well as what it's doing now. So it does have a future view.
Yeah. Yeah. And there's a lot more batch in systems than scheduled batch. Some shops have as much non-scheduled batch as they have scheduled batch. And so the job scheduler is not very helpful with that. It can only control what it controls.
Thank you.
Anything else? I'm thinking I'm going to have to do a session next year on using IWS workload schedulers management facility is much better rather than monitoring.
Yeah. Yeah, ideally, a batch automation solution will work closely with the job scheduler to achieve its goals, because that's how the job scheduling defines those goals. So that's how a proper batch automation tool should work, and look to the market.
Yep. Okay, if there's nothing else, no other conversation. I mean, you know, we're we're all here to chat to each other. We would be doing if we were in the same room, but okay. All right. So, well, thank you very much again. I'm not going to repeat all the closing stuff. We can, and I hope to see you again at the last GSE session, apart from the wrap up in a short while.
Thank you all.
Thank you. Talk to you all later. Bye.